Greetings everyone! Today we're going to explore scientific notation operations. In your foldable that I've provided you, let's start off by going over the rules for multiplying with scientific notation. Step 1 is to multiply the decimal numbers, meaning your number in front of the times 10. Step 2 is to add the exponents, because you're going to have 10 to the second times 10 to the fifth, and we know on our exponent rules that when you multiply like bases, you add the exponents. Step 3, make sure you have one digit, non-zero, in front of the decimal, meaning in front of the times 10, this number needs to be between 1 and 10. So you might have to move the decimal a little bit. Now notice in our foldable we have an asterisk there, so let's explore what we need to do if it's not between 1 and 10. In the middle of your foldable, if my number is not between 1 and 10, let me give you a quick example. Let's say I have 23.56 times 10 to the negative fourth. That number is not between 1 and 10. I have to move the decimal left once. So let's read through our rules and see what we need to do to our exponent. To change the exponent, we want to count how many times you move the decimal. We went once. If you move the decimal forward, we need to add that number to the exponents. Technically, this is forward. So let's use the word left as well. Please fill that in on your foldable. And since I moved it left, we add that number, that +1, to my exponent. If I go left 1, my exponent goes up 1. So my new value is 2.356 times 10 to the negative third. The opposite is also true. If you move the decimal back, or please add in right. If you move the decimal right, subtract that number from the exponent. Let's do a full example following our steps. Please fill this in and write the step numbers. Step 1 is to multiply the numbers out front or the decimals. So I'm going to have a 3.7 times a 6.2. Definitely need to use your calculator. When you multiply those two numbers, you arrive at 22.94. Step 2. We need to multiply the second piece of our scientific notation. If I have 10 to the 6th times 10 to the 4th, I add the exponents, and I arrive at 10 to the 10th. Step 3, if I put those two steps together, I currently have 22.94 times 10 to the 10th. Is my number between 1 and 10? It's not, so I have to do a little bit of work. I need to move my decimal left once, which means my exponent goes up 1. I add 1. So my final answer is going to be 2.294 times 10 to the 11th. Notice that visual pattern. If you're a visual learner, you can see that I move the arrow left and I move the arrow up. That might be a connection for you as we move forward. Let's talk about dividing. Steps are very similar. In your foldable, it says step 1, divide the decimal numbers. Step 2, subtract exponents. Well, that makes sense. If I have 10 to the 5th divided by 10 to the 3rd, I subtract those exponents and get 10 to the negative 2nd. Negatives are okay because this is scientific notation, so we don't move them to the other side of the fraction bar. And again, step 3 is exactly the same. You need to have a number between 1 and 10. If you don't, you got to move the decimal around. All right, let's take a look at the example in your foldable. Let's follow along with the steps provided. Step 1 says to take the numbers in front and divide them. So I have 1.2 divided by 2.4. That gets me 2.5. Step 2 says to divide our base 10s. Currently, I have 10 to the 8th divided by 10 to the 3rd. When dividing like bases, that means I subtract the exponents. So I have 10 to the 5th. Step 3 says to put those two numbers together. I have a decimal value of 0.5 times 10 to the 5th. Can I leave my final answer like that? I can't, because this number is not between 1 and 10. So if I move the decimal to the right one, that means I have to decrease my exponent by 1. So my final answer will be 5 times 10 to the 4th. Let's talk about adding and subtracting. We're going to go over 2 ways to do this. I'm going to call this the steps way. So if I use my steps, step 1 is to make sure the exponents of both numbers are the same. Meaning if I have 10 to the 5th and 10 to the 4th, I cannot add those. Okay, they need to be the same. So I might have to go back to that middle portion of your foldable. I might have to make them the same by moving a decimal. Step 2, we want to add or subtract the decimals. And don't forget to line up your decimal points if you're doing longhand subtraction. But you can only do this when the exponents are the same. Step 3, make sure again that your number out front is between 1 and 0, or excuse me, 1 and 10. You might have to move the decimal again. Let's take a look at an example. So I intended this to be adding. Let me change that to a plus sign there. So first step is I need my exponents to be the same. Currently I have a 4 and a 6. So for step 1, sometimes there's some strategy on which one to pick, but I'm just going to pick the 4, and I want the 4 to go up to a 6, which means I'm going to add 2. Okay, which means I'm going to have to move my decimal left 2. So my new number is going to be 0.054 times 10 to the 6th. So take a look at that again. I increased my exponent by 2, so I moved my decimal left by 2. Let's bring the original number back down. This was a 9.7 times 10 to the 6th. Plus sign in the middle. Step 2, I can actually add these now. So using my calculator, if I take 9.7 and I add 0.054, how easy is that? That works out pretty nice. We arrive at 9.754, and you keep your times 10 to the 6th. Step 3, make sure that your decimal is between 1 and 10. In this particular case, it already is. I'm going to show you an alternative that will only work for adding or subtracting. Okay? If I take a look and I want to expand both of these and add, I can do that. So another option that I'm going to provide you is to avoid the rules. Okay? I'm okay in this instance if you avoid the rules. I'm going to expand, meaning if I take 9.7 and I move the decimal right 6, 1, 2, 3, 4, 5, 6, and I have this large number. If I take 5.4 and I move the decimal 4, 1, 2, 3, 4. Some students find that much easier to line up and add. So I have 9, 7 with 5 zeros, and I have 54 with 3 zeros. I can old school add those up, draw a bar, line up your placeholders, 4, 5, 7, 9. Then I can go back to scientific notation by moving the decimal. 1, 2, 3, 4, 5, 6. That means my final answer no matter which form I use, is 9.754 times 10 to the 6th. Notice it's about the same amount of work either way. So again, you can follow the rules or expand and add. Let's talk about power of a power for scientific notation. First, make sure you distribute the exponent to everything. Well, you guys already know this rule. Remember, if I have 2x quantity squared, that means I have 2 squared and x squared. So the same idea is true. Distribute the exponent. Step 2, evaluate the base to the power. So in this case, what is 2 squared, right? You need to actually calculate that out. Step 3, we multiply the exponents. Remember, when we have a power to a power, we multiply the exponents. So these are our exponent rules from before. These are old news. And the last step, as always, is to make sure your number out front is between 1 and 10. Let's put this into practice and try an example. Step 1, we want to distribute that exponent. So I'm going to take that 4 and it's going to go to both pieces. I'm going to have 4 to the 4th times 10 to the 6th to the 4th. In your notes, please write these steps out. I know when you go to practice problems, you can probably calculate these as you go, but for now, let's show our work. So then let's go 4 to the 4th. Remember, that's 4 times itself, 4 times, that's 256. Step 3, we want to multiply the exponents. So if I have 10 to the 6th to the 4th, that becomes 10 to the 24th. It's a big exponent. Step 4, let's put our pieces back together. I end up with 256 times 10 to the 24th. Now, is my number between 1 and 10? It's not. I have to do a little bit of moving. So currently my decimal's here. I'm going to move my decimal left twice, which means I need to increase my exponent by 2. So my final answer is 2.56 times 10 to the 26th. It's a big exponent, and that's okay. Now, I'm going to just quickly scroll through these questions as a way for you to practice. You can choose to write these down. The answers are provided in Google Classroom on the notes PDF that I've provided to you. So please use the rest of this video for your own practice. All right, you've reached the end of the video. So if you have practiced those problems, paused, worked them out, check your answers from Google Classroom. Then also make sure you check Google Classroom for your homework. What do we need to do? What's assigned? Make sure you stay up to date. Make sure you check PowerSchool for any missing assignments. And then just take a look at where we are in the calendar year. Is the end of the quarter coming up? Take a look, see what you need to get in, what you need to change before grading is finalized. If you have any questions, make sure to let me know. And until next time, have a good one.